Thanks a lot for the introduction. It's really a pleasure to be here today. So thanks to Polydesign and Residio for having me here. It's actually a joy for me to at least be virtually back at Politecnico, where I spent many years during my studies, many happy years during my studies and early stages of my research. So today I'm actually gonna talk about water demand. I'm gonna focus on water demand, and I'm gonna focus on the residential sector. This is one of the topics actually that we research on here in Berlin, where I'm heading the chair of smart water networks as part of the Technical University and the Einstein Center Digital Future. That's a center focused on digitalization and digital development in society, environment, health, and many other sectors. So I'd like to actually thank also the previous speakers for introducing several challenges that are actually tackling now our water sector globally at the large scale. So there were solutions about cities, solutions about global challenges or water transfers, water embedded in other sectors like energy, food, and so on. And I'm going to actually dive now to a way smaller scale and then go back in the final part of my presentation to the global scale. And when starting this journey from the small scale, I actually go to the residential sector, which is one of the topics of this event. And I pose this question that has been many times posed to myself, to me, and I also posed myself a few times, that does the residential sector matter for urban water management? So in terms of numbers and statistics, an idea of how much the residential sector matters was given already in the previous presentation. There are sectors that are definitely larger in terms of water use. So if you look at this statistic from the European Environmental Agency, the EEA, you'll see that, as was already presented by Professor Rosso, the agricultural sector, electricity, and other sectors like mining and so on are definitely using more water. However, the residential sector, which is accounting on average for about 11.6% relative to all economic sectors in terms of water use, is actually key and does matter in several cases. Think about, for instance, cities, where households are really dense and the residential sector is probably the main one. So depending on the scale we look at, the residential sector matters. And if this is not enough, I hope I can manage to convince you that it matters also by basically posting here these two numbers related to energy consumption and greenhouse gases. Basically, if you consider the urban water cycle, it's not just about water. We've learned this in the previous presentation as well. And basically 70% of the energy consumption of the urban water cycle is related to the final use into homes. And 67%, so basically same ratio of greenhouse gases is due to the final use of water into homes or the residential sector. So I hope that with these two numbers, I managed to convince you that yes, the residential sector matters. And so we have to deal with that somehow. And here's where I'm happy to introduce the concept of demand management, right? So if we want to somehow foster people in homes to use water efficiently, reduce waste, reduce losses, and use water wisely, basically, there are a few things that we need to know. First of all, how much water is being used nowadays. So if we want to change how much water is used now, we first need to know the status quo. And obviously, let's say having traditional meters like the one you see in the picture is probably not ideal, doesn't provide so much information. It's offline, you don't get online information, it's analog and so on. Likely, new technologies like smart meters, which are meters that can record water consumption at home, and they're equipped with some digital modules where you can display, store, and even send data about water consumption in a centralized database, then this provides a lot more information. So first thing is getting knowledge about water demand. Second one is about its determinants. If we want to change the way people use water at home, then we need also to understand what the drivers for using water are. And this is somehow tricky. There are many potential determinants. You see a few of them listed here in a tree sort of structure of this figure. And some of them are somehow easy, or let's say accessible, at least to retrieve. They're called observable. You can measure them, for instance, the number of people living in the house, the size of the garden or so. But some of them are more tricky to get. For instance, those that we call latent, those that relate more to psychology, to the value that people give to water, to the habits of people, the way people behave and so on. These are hard to define, to measure and so on, but still can be potentially powerful drivers of water demand. And finally, obviously, the external ones that we cannot really control and define the context, like rainfall, temperature, also water price. The utility can control it, of course, to some extent, but it's not directly something that users can control. So once we get to know better about these two items, water demand on the one side and the determinants of water demand on the other side, the potential to actually foster more efficient water consumption is enormous. So basically, as you see in this loop, basically what I'm trying to say is that if we have a better information about consumption, water consumption, and more information about the behavior of the customers and the users that we can somehow then express in some mathematical terms and so on, we could then go back to our community of consumers with different personalized demand management strategies. So acting on technology, behavior, finance, and so on. And we can choose the right portfolio of action, or let's say the most suitable portfolio of actions based on the actual different demands that we have in our study site, because obviously not all people use water in the same way. So probably the average water demand is not representative of all the different heterogeneous behaviors. Now, to give you an example that is more tangible, basically what I mean by demand management strategies, one typical example is what we call also restrictions and legislative intervention. Maybe some of you are aware of water restrictions that were put in place by the governor of California, Jerry Brown, to respond to the heavy drought, one of the many droughts that actually let's say challenged California over the years, and restrictions were needed in 2015 and then again in 2018. And this is somehow a top-down intervention, right? So it's coming from the local administrators. They see the situation and they impose a restriction on water consumption. A different way actually to deal with that's another example of a potential water demand management strategy could be instead to provide more information to people. And so here it becomes a little bit more bottom up, where people actually understand better and change their behavior because of a better knowledge and awareness of water consumption. So for instance, there are devices that can actually display and provide information about water energy consumption, for instance, to customers. And I'm going to focus now for the next part of this presentation, because before jumping back to the global scale, I'm going to focus exactly on this particular type of intervention. So how can we foster behavior change and water conservation with voluntary intervention? So nothing mandatory, nothing top down, but more something that is coming then back to the users to change their behavior in a more voluntary way. And I'm going to actually provide an example and some insights from a European project that's called Smart H2O. And it's a project that I had the pleasure to actually work at when I was at Politecnico, and then I could continue working on some results that I'm going to show in a second later on. After moving to Berlin, the project involved a big number of different partners. We had over 10 partners with water utility, universities, small, medium enterprises, and so on, and was led by the Swiss University of Applied Science and Arts. Basically, what we tried to do in this project, what we actually did in this project, was to increase people's awareness about their water consumption, trying to foster behavior change. And we implemented a platform that you see here. You'll probably see a very similar loop to the loop that I've shown in some previous slides, where we have some smart meters recording water consumption at the level of individual house. Then we did some data analytics, also on anonymized data, so to protect customers' privacy and data security. And then we had a web portal. I'm going to show this a similar picture, a bit zoomed in a second, where basically we try to give this information back to the people in order for them to learn more about their water consumption and ways to save water. Final question of the project was, is this actually worth the effort? Do we achieve any water conservation result by implementing all of these? We'll see that in a second. So we provided about 334 homes in Valencia, in Spain, with a portal similar to the one that you see here on the right-hand side, where you see water information was displayed in several ways, from more complex ways to user-friendly ways, and people could get points by performing actions in this portal. So they could play with the water consumption, they could read and watch videos about water saving and so on. They would get points to be used then in a marketplace. So there was this gamification mechanism here, and also peer pressure, so that you could see also other people's behavior and achievements and be fostered in doing more and better, and so on and so forth. And we also had games, so to engage also people of different age. We had a card game that's called Drop, that was primarily targeted to kids, to school children, but also with a digital extension with a QR code and an app, was basically a tool to connect the real world of tangible things with the virtual world of this web portal and information, right? So we had a series of different items we put together in this platform. We provided these homes with these, we provide them with feedback on water consumption and ways to save. And then what happened? So we see the main result here. We observed actually some behavior change. You see here, these two subplots are basically representing similar thing. You see two colors. Blue color is the group of homes that we engaged with our experiment. And then we had a control group in gray, a group of users that were not involved. So for us, that was the terms of comparison, to see whether our intervention was actually creating differences between people that were engaged and people that were not. So this is a case control experiment, so with a case control design, and it's a longitudinal study, which means that we replicated this measurement and analysis over the years. You see 3 years here. And I'm representing here basically the water consumption change in percentage. What you see is actually that the users engaged in the program, so the blue ones, actually saved water by more or less 4% on average in the short term. And then in the long term, they saved even more, and then they tended to go back to their original consumption. This difference is actually enhanced way more if we compare this with the control group, because in the same period, because of very hot and dry summers, the control group people actually increased the water consumption by 20 to 30%. So we were rather happy with this result on average. However, we were a bit concerned by the fact that after 3 years, basically, then this saving behavior was somehow going back to the original situation. So we wanted to understand whether this was actually true for all customers or just for some of them. We grouped them, and you see here the patterns of their water behavior over 3 years. So basically what you see here is whether they increase or decrease water consumption. And the 5 top behavior that we found most frequently in our group were the water savers that saved water either in the medium, long, or short term. So they amounted to more than 45%. So large part of our customers actually saved water under this intervention. There was a 10% actually that was experiencing this rebound effect. So people that after some time probably lacked a little bit of boost and motivation, or maybe information to actually maintain the level of water saving. And then we had consumption increase customers that instead increased their water consumption during that period. So probably the intervention was not sufficiently effective for them. Now, one last result, before I jump to the final part of this presentation, one last result that we found particularly interesting is that those users that were provided with a finer resolution information, so water consumption at each hour, saved a lot more water than those that were provided only with data at the day scale. So apparently information matters. And obviously in the era of technology of big data, and more accessible and more distributed information, out of this, we asked ourselves a bigger question that is, okay, but how is digitalization and how is digital technology actually embraced nowadays by water utilities? Because sometimes we've seen that the full potential of technology is not exploited. There were previous studies, actually one of them very quickly published by the International Water Association, was showing that there is this learning curve of technology. So digitalization is more a journey for utilities. It's not really just a disruptive event, right? So there's a gradual increase. And we wanted to verify this ourselves. and also quantify these. So we set up a global survey for water utilities with several partners you see here. That's called Smart Water Survey. We collected information from over 60 utilities worldwide. You see the distribution here, most of them in Europe, but also North and South America, Asia, Australia, and Africa, with a lower representation. And we asked them several questions, which now we don't have time to provide in detail, but basically about the 5 categories and subdivisions of the water cycle that you see here. So water resources, network, customers, wastewater, and IT. And we tried to identify the key enabling technologies. And with this, I'm basically moving towards the closure of my presentation. And for each subdivision, we listed a series of technologies. You see them here listed with icons. And on the x-axis here, you see what is called technology adoption rate. So the higher, the more the technology has been already adopted and strongly planned for the future as well. And now, without entering the details of each individual technology, I can actually take questions on this later. But we can see that there's a trend here, right? So if we think about water sources and distribution, where the utility has to provide clean and high quality water and drinkable water to the customers, technology is already quite advanced. And then to a lower extent, it is coming also in the wastewater and finally in the customers and demand management, which is the subdivision that we focused a lot on today. Interestingly, what we found by analyzing the answers of the utilities is that what is driving this technology advancement in this customer and demand management subdivision, but also in general in all others, is of course also related to some conditions like climate, motivations, and so on, but primarily so far is driven by economic factors. That was by far the largest factor that they mentioned, and governmental influence. So economic ecosystems and businesses should enable these digital technologies to actually help the water world to enhance their capabilities of extracting and analyzing and using information for water management, as well as the political and administrative sector with the governmental influence. So to close this here, basically, what is his suggestion is that, yes, information is important. Yes, technology is coming and can help utilities across the whole water cycle and the residential sector. But actually, technology provides just the tools, right? So in order for technology to be used effectively, to be used efficiently for enhancing the climate neutrality as well of water utilities, the water security, and here we could put a series of other keywords similar to this, then there should be a call for joint actions by water managers in utilities, customers, and personnel working in utilities, technicians, and regulators to actually move towards the common objective in this case. So with this, I'd like to thank you a lot for listening to my presentation, and I'm happy to give the stage back to the moderator.